Okay, this is our last lesson in our probability unit, and today we're going to be talking about permutations and combinations that we're going to use to find the probability of items. So this first one, we have a game of high-low. It's a probability game for two people. One person is the low player and the other person is the high player. Each person rolls a standard die, and then the players are going to subtract the smaller number from the larger. And if the dice difference is 0, 1, or 2, then the low player wins. And if the dice difference is 3, 4, or 5, the higher player wins. So before playing the game, do you think this game is fair? And explain your reasoning. So please pause and write down what you think. And when you have finished writing, then unpause. Just to give you time to do that. Okay, so part B, with a partner, play this game 20 times and record who wins each round. After completing the 20 rounds of the game, create a sample space to show all the possible outcomes. So I was going to try to help you figure out a good way to organize the information when you are putting it down. And I don't know if this is going to let me do it, so let's just find out. There we go. So I have a table, and basically when you have two dice that you're rolling, you're either going to get on one of them 1, 2, 3, 4, 5, 6, because we have 6 sides to a die, and 1, 2, 3, 4. So this is kind of just to help you distinguish between the two dice. Okay, so what's going to happen here, as it said in the rules above, you're going to subtract the two numbers. Okay, and when you subtract them, I'm going to put a different color in here to get the outcome. Okay, so 1 minus 1 means obviously is 0. 2 minus 1, we're always subtracting the larger. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1, 5 minus 1, and 6 minus 1. And so hopefully you can figure out that same thing is going to happen this way. 2 minus 1, so forth and so on. So you will need to put this chart on your paper. 2 minus 2, and it's going to follow this pattern. 0, 3 minus 2, so forth and so on. 0. I guess I should have paused it, but you can pause it. Get it filled out because you're going to need it to answer the questions. Okay, so that is your sample space to show all the possible outcomes for the game. And if you go down to the next question, it says, based on the sample space, is the game fair to both players? So basically, how do you know that's the sample space? Those are all the possible outcomes when you roll 2 dice. Now, if you're going to figure out who wins, the low or the high, a low player wins if you get 0, which is here. Oh, silly me. Y'all probably yelling at me. Why did I put a 2 there? Because that, of course, is supposed to be a 0, because 6 minus 6 is 0. Okay, no, nothing lost. All right, so down here, low wins because those are all zeros. Low wins if you get a 0, a 1, these are 1s, and a 2. So those are all the possibilities, all the times that the low, whoever is being the low player, would win. So if we put that down and figured out the probability, if you are the low player, the probability of you winning is how many of those are there? In that, there are 24 out of 36. Okay, you've got 6 this way and 6 this way, means a total of 36 possibilities. And the probability that the high player wins is 12 out of 36. So clearly you can tell from the answer to that question is the game is not fair to both players. So that's your evidence to describe that. It's not, so you have to tell me in what's left, what space you have left, how you would change the rules so that both players have an equal probability of winning. Okay, so do that. You can pause it and do it now, or you can do it later. Look down to the next problem, because I'm really just trying to get you started on this. Die A has 4 8s and 2 3s on its faces, and die B has 4 5s and 2 9s on its faces. When both dice are rolled at the same time, each face has an equal probability of landing on top. 2 players are going to play a game, and this time we're not going to subtract. Basically, how does this work? The person with the higher number on top wins the game. So again, I'm going to try to organize our information here. So let's go back to similar to the way I did up there, but what I have here is not as much room. So let's see what we got. So one of the die had 4 8s. So I'm going to go 1, 2, 3, 4, 4 8s and 2 3s. And the other one had 4 5. So 1, 2, 3, 4, and 2 9s. Okay, so now when I figure out, okay, this time when we're looking at the intersection of these two things, the one with the higher number on top wins. Okay, this was die A and this was die B. So when I look at the intersection, then clearly you can see that 8 is higher, 8 is higher, and then B is higher. 8 is higher, 8 is higher, and then B is higher. So what you're going to do is you're going to go figure out the intersection and fill out the rest of that and then answer the questions. So again, just helping you get started and helping you get your information to make it easy to answer the questions. All right, turn the page. If mine will do it. The next thing that we're going to talk about, if I hit it again, it's going to go twice, but we're going to do it anyway. All right, so now the thing that we have to keep in mind is sometimes our sample spaces are really large. What we just did is we wrote out all the possibilities, but sometimes those sample spaces are so large that it's not feasible to write them all out. So we use 3 different ways of figuring out what that sample space is. One is a basic counting principle, one is with permutations, and one is with combinations. Okay, so the first one that you have is the basic counting principle, and it is defined as the product of the number of ways the events can occur. Now, this particular one is only 2 events, but it doesn't matter how many events, as you see, as we're going to keep going. If one event can occur in P ways and another event can occur in Q ways, then the number of ways that both events can occur is P times Q. And a very simple example of that. In your closet, if you have 3 pairs of pants and 5 shirts, how many different outfits can you make? 3 times 5, or 15 different outfits. And we're not saying outfits look great, but, and as it says, it can apply to more than 2 events. So however many different events you have, you're going to multiply all the different ways that it can happen. So an example is this first one. In how many ways can a call letter, in how many ways can the 4 call letters of a radio station be arranged if the first letter must be a W or K and no letters repeat? So what you're figuring out is how it's similar to the shirts and the top pants. You've got to figure out how many different choices you're making. Okay, I have 4 call letters, so I like to put down blanks. I have to make 4 choices. I have to put a letter in for the first, second, third, and fourth blank. So there's so many different ways that can happen, and when I figure out how many different ways, I'm going to multiply all those ways together. Now, they told me the first letter had to be a W or a K, so that means I only have 2 choices for the first blank. Okay, what do I have for the second blank? How many letters are in our alphabet? Yes, there are 26 letters in the alphabet. However, I just used 1 letter right here. So if I used 1 here and there's a total of 26, that means there's only 25 letters left. And they told us the letters cannot repeat. So if I have a letter here and a letter here, then I'm left with 24 letters and then 23 letters. So you multiply that out, and you get that you have 27,600 different ways for call letters of a radio station. And in case you didn't know, W means you're east of the Mississippi and K means you're west of the Mississippi. Okay, so that was the basic counting principle. The next one that we have is permutations. So you're going to go down, and permutations, it's basically a modification of our counting principle. And what is most important about permutations is the fact that the order matters. Now, let's keep going and I'll talk about that. The number of arrangements of n objects taken r at a time, here's your notation, NPR is what that looks like. And there is a formula. There's also a button on your calculator that you can use and you need to find. You might find it if you don't see it right away. Then look for that button under the, some of y'all who have the TI, not a horizontal fraction bar, look for a PRB or probability button and you'll see this option here. Okay, but an example of how this is used, one thing you do want to know is that larger numbers always first. So I'm going to do an example here of just showing you how this works. 7P3. And actually, before I talk about that, I need to make sure y'all know what this little thing right here means. Okay, N with an exclamation point is read N factorial. Okay. Let me put it in the formula and then I'll explain to you more of what that means. So 7P3 means that I'm going to have, I didn't need that much space for that, 7 factorial, and on the bottom is 7 minus 3 factorial. So that is 7 factorial over 4 factorial. Now, if you don't know what factorial means, listen closely, because that little exclamation point tells you to take all the numbers starting at 7 and work your way down to 1 and multiply them. So it's 7 times 6 times 5 times 4 times 3 times 2 times 1. And then on the bottom, you're going to have 4 times 3 times 2 times 1. Now, surely you can see you got the same thing on the top and the bottom. Those cancel, so I'm left with 7 times 6 times 5, which is 210. So 7P3 is equal to 210. Now I'm going to show you another way, because some people might already know this. But when you see something like this, 7 factorial over 4 factorial, you can always write it all out like this, but you can also think about it, so you could go from here to here and write 7 times 6 times 5 times 4 factorial, and you stop at whatever you have on the bottom, since I have 4 factorial, or the bigger one on the bottom. Because if I have a 4 factorial on the top and a 4 factorial on the bottom, those are going to cancel. That's basically what we did right here. And you'll end up with the same thing. It's just a shorter way of doing it. Okay, the next thing you need to know, there is a factorial button on your calculator. There is this button on your calculator, but there will be a problem on your test that looks just like this. And that means you have to write this out. So you have to know how to do it. If it is within another problem, then you can use the button on your calculator. You can write this down as you're solving a problem and say, oh, that's going to be a permutation. So you write 7P3, and then you can just use the button on your calculator. Okay, moving on. Those are problems for you to work. Number 7, I put it on the calendar, but in case you, why did it do that? In case you don't pay attention to it, you get to skip this problem. So draw a nice big X through it. And now we're going to go down and, oops, I missed that. Nope, those are more problems for you to do. Yeah, you do need to do number 8. Skip to the back. And the last thing that we're going to talk about is something called combinations. So this is the last type way to figure out large sample spaces. Okay, so a combination is used when objects are selected, but this time the order does not matter. So permutation, the one that has an R in it, is when the order matters. Combination, it does not. And here is the formula to calculate. And what I'm going to try to do in this space is, let me go see if I can do 7C3, because we just did 7P3, and this way you can see how they relate. So if I did 7C3 with this formula, that means I have 7 factorial over 7 minus 3 factorial, and then 3 factorial. Okay, that equals, that thing's so annoying, 7 factorial over 4 factorial, 3 factorial. Okay, and this is what you'll have to show me when you do one of these by hand. Okay, and then if you remember that little shortcut, I'm going to take the bigger one. So I'm going to do 7 times 6 times 5 times 4 factorial on top. And I have a 4 factorial on the bottom, but then I have 3 times 2. Oh, stop that. 3 times 2 times 1 on the bottom. 4 factorial goes away. And then 3 times 2 is 6. So what does this equal? It equals 35. So what's happening here, okay, the difference between combination and permutation, the order doesn't matter. So if you were thinking about if you had 7 letters and you're choosing 3 of them, A, B, and C is the same thing as C, B, and A when the order doesn't matter. If the order does matter, that's a different combination. So that is the thing that you have to keep track of when you're working through these problems. The last thing that I want to tell you is all of these will be worked out for you after they'll be put up in the announcements, the worked out versions. You can check your answers after they are due. So check them, but I want to tell you to please make sure that you understand this last problem. Okay, you'll see it quite often, and you might see it on your test. Okay, hope you'll have a great day, and let me know if you have any questions. Thank you very much.